Okay, sir. Good afternoon, sir. So, today I'm going to actually redo my t-test part of my last submission before this because I submitted yesterday on my lab assignment 2B, and I realized that there's a lot of mistakes actually on t-test part. So, which I am going to redo it today, and I'm going to send it to you by today. So, I'm going to go straight away to t-test because I think there shouldn't be any problem in the codes. So I'm going straight away to t-test because my t-test is seriously there's a lot of mistakes. So maybe I didn't go through your video properly. So I have to do it again. So I will be doing it again. So before that, to make sure that I really understand the question, because maybe the question I didn't understand it properly last submission. So I have to understand it properly. So I'm going to read the question. So basically, my question here is on variance, which is lab assignment 2B. So which is on variance, and I'm going to use to measure my contrast of an image, where I'm given 30 samples of images, which is all here, all my 30 samples of images. Okay. So in all my 30 samples of images, I'm also have to use to load the contrast here. I'm using I'm adjust because before this I use I'm adjust to actually make high contrast. So I'm going to use it to lower my contrast. And you have to use t-test function in Microsoft Excel, which is t-test function is already there in Microsoft Excel. I just have to use that to actually check the variance for the two class of images. What are the classes? Because I'm using here is lower and the good lower and high contrast images. So I'm going to check within that image that two pair of images, and I have to state on my objective, design, and to perform each step. So I've already performed each step. Basically, is the coding part, and the design of the experiment is basically I'm going to change it to grayscale, and then later on after that I'm going to compare with the two contrast because I'm going to use IM adjust to actually lower the contrast, and then from there I'm going to share my code, and then I'm going to use the t-test function. And then lastly, I'm going to conclude this by using the output of the t-test. Okay. Okay, my coding is already here, which I submitted before this. So the same coding actually I'm using for. Okay. So for me to explain each and everything, I'm going to explain each and every code. The coding is already here. I'm just going to explain for each and every code. Okay, now I'm going to read the files. So I'm going to explain you one by one about the files. Okay, so I think I have to block a comment at the end of the file. So I'm going to do it here. Okay, so I think shouldn't be any problem now. Okay, so I've already blocked the comment at that below. So now I'm going to clear this whole thing. I'm going to restart it again because I don't want any problems here. So make sure everything runs properly. So I've commented down there, and now I think there shouldn't be any problem. Okay, now yeah, I'm going to talk about total file list. Total file list is 34. Why I'm having 34 here? Basically, I'm using image directory here. My image directory is empty. Is just because I can't paste anywhere, path to anywhere, because basically my variance images is inside my IP folder, my part, but I cannot bring it here because Octave Online don't allow to read files from directory. So that's why I brought all the files here. And there are 34 just because there are two subfolders inside the file, and there is two.m file, which is the file that I'm using, and another one more is in the myscript.m. So since there is altogether 34 files, and you see this file list, I'm going to tell you what is file list here. Since I'm using file list, enter. So file list here, you see there are, as I told you, there are 34 altogether total files times 1. And now here we're going to use name, bytes, each directory, and all these. Okay, so if you see my each directory here means all these things. So this is called field name. So my field name that I'm always going to use is on name. So a name that reads on file and folder name altogether. All the files will be readable and it's already in character. And folders is where the location of a file, and date is basically the modification date, which is the timestamp. And bytes basically is in double. Bytes is basically the size. So if you see my Octave online version, I am not able to read bytes that is more than 1 million. So 1 million bytes is not able to read. So there are that is why some images will not be able to read and will not able to show. And each directory is basically one is for folder and 0 is for file. Later I'm going to show you what each directory is. And date name is basically the modification date and the serial date number, which should be in double. So now the important thing here is on name. Sorry, file list dot name. If you see, all the names has been readable, so there are 434. As I told you, there are 2 subfolders. That is why it's in dot dot. And all these are files included with my assignment that I'm using now, and also my script file .m. So altogether there are 34. If you see file list.isdir, if you see here, all 32 files has been showing 0, because 0 means files and 1 is basically folders. So there are 2 folders, as I told you before this. There are 2 folders here, this dot dot thingy. And yes, we have bytes, and I've shown you this. So now we are moving forward to this part, Control X. Control V. Since we have to use N, Control X, and we are going to move here forward. Okay. So now what are we going to do? We're going to read this. So I'm going to explain this. So now we're going to call the total files into here, and then the file list is directory. As I told you, we don't want all the subfolders, and we don't want something that is not related to JPG file. So all the files that we're using here is all JPG. JPG is basically the format of an image. Okay, and there are so many formats, PNG and SVG, and so many formats for image. So now here we are using JPG. Why we using all JPG is because easy for us, for me especially, to actually extract all the JPG file, because we all want 30 images only. Okay. So yes, and is empty is basically the one that is shaped like a worm here is basically we don't want that. Okay, we don't want folder, we don't want the image that is not related to JPG. So that's what it means here. And str find, basically we are going to find within the string. So that is what str find is. Empty is something that not related, so it will show logical whether it's true or false. So I'm going to run this. So if you see the I is equals to 34 as usual, because I is equals to 1 and its total file is 34. So now I'm going to go for the next part, which is on reading. Control X. Sorry, Control Z. Okay, I'm going to take this thing off. I don't want to comment this. So I'm going to run this. Okay, this is basically to read image. So I'm going to read the image. I'm using image directory because I use up here, and the what are the things that I need is basically file list I.name. So I want all the names to display. What are the names here? Just now we have already found out all these names to display on above the image. So that's why I'm using here title. and I'm going to show all the image. Image is basically I'm reading all the files from here, and then pause is basically for 1 second it will repeat the images. So because there's 30 images, all the images should be displaying. So when we want to display all the images, we pause it with 1 second. Okay. Okay. So I'm going to save this. I'm going to comment this because we don't need all this. Okay. So now I'm going to run save and run this. So some images are not working here. It's just because those images is not able to read, will not be able to read. So as I told you, because the rasterization, it's just warning, it's not an error, because it's not allowed because of the bytes. Can you see the maximum bytes given there? It's very low. The bytes is given just for 1 million, but the bytes I mean the images that we're using, the bytes is very, the size is very big. Okay, so all the images is appearing, those that is able to appear, so it will be appearing. So I'll show you those images later. Okay, if you see all the some certain images have already appeared, so I'm going to show you this. Okay, if you see okay, if you see these images, the last images, which is a vase, very beautiful vase. Okay, see the images of this portrait. So if you see, if you see this is it's correct or wrong, if you see here, the same thing, the same name is being appeared here, over here. So this is what we call as the file list name. So all the name is correctly written. So a few images only I can appear here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Altogether, there are 16 images that am able to read. Okay. So I've justified the reading part and I verified that. Okay, we're moving forward now. Control X. We're moving forward here. Control V. Okay, so we're going to take all these things. Since we're going to use conversion for RGB to gray, but before that we're going to comment this. We don't need this anymore. We have already I've already verified that. So now we're going to do for this. Think there's no error, so I think it's working. The same thing having a problem because some certain images not able to read, because as I told you, because of the rasterization plot, because the image is very big in terms of the bytes. Let me display all the images. Okay. See the pausing part. So every every 1 second, the images will every 1 second the images will be popping up. So I have to because this thing is basically on seconds, so that's why 1 seconds. It's always adding 15 seconds. I always have to add 15 seconds to actually appear all the images because there are 30, which is a lot. So yeah. Okay, so I basically okay, I think the images, some of the images is already appeared. So before that, I'm going to show you what is meaning of RGB to gray. RGB to gray is basically to change from RGB to gray, grayscale. So to actually, why are we making to grayscale? So easy to see the contrast when we have all types of colors. Since there are so many colors in the image, so it's difficult to actually see whether it's high or low contrast. And if it's in a grayscale, which is in the shade of gray, black and white, so it's easy to see the contrast. So that is what it means by RGB to gray. So let me verify that what is meaning of RGB to gray. So it's basically to convert true color images, which is RGB. RGB is red, green, blue, all that very colorful images to actually grayscale. So that is what it means here. Okay. So now I'm going to verify this with showing you the image. So if I labeled here as grayscale and original. So this is the original image just now we see. Okay, see original image. So very beautiful picture here. And see the eye picture. So if you see there's so many colors here, I think there's many colors here, and when you see it, it's already in black and gray and white colored. Okay, these are a few images that are formed for grayscale. Okay, so getting back to lowering part, now we're going to lower the contrast. To lower the contrast, let us we comment on this. Okay, so now we're going to take this thing, Control X, and we're going to bring here. Okay, so now what are we going to do is we're going to see, we're going to adjust the image by using I'm adjust, like what in the question here written I'm adjust. So we're going to do that. Okay, to display that, we're going to use I'm adjust, I'm gray. So what are the image that what is the image that I have to input? It is basically I'm gray, this image I have to put it here, and I'm going to use that I'm adjust, and I name it as IMG gray poor. So basically we're going to since we're going to lower the image, so I'm using poor as the poor as stands for lower. So 0 1 here is basically the input. Okay, the input here is, since it's in gray, so basically it's the input here is 0 1. 0 here is low in and low out, high out, high in. Sorry, low in and high in images that I'm going to actually it's a full range. So what the range that we have to put it in, and the output here will be this, which is low out and high out. So 0 will change it to 0.3, and 1 here will change it as 0.7. So if you see the decreasing part is 3 percentage. And then I subplot it as 1 2. So basically what is the meaning of subplot? Okay, I forgot to actually explain here. Subplot here is in the first. Okay, if you see, I'm actually putting it as there are one row for 1 year means as one row, and 2 year means 2 columns, and it is in the first place, whereas I'm gray 4 will be in the second place. So I name it as high contrast image and low contrast image. For poor is low, and for normal one is high. And I pause it with 1 as usual. So I'm going to run this. If you see certain images that was not displaying just now, now it's displaying because the contrast has been reduced. Okay, we're just going to wait for some time to actually display all the images. Okay. Okay. So if you see, before we seeing the images, you see IMG gray poor. So all the images is 179, and for those the normal gray is 255. So that's the ratio, and the images here we don't have to see that. Okay. So let us see the image. So if you see lower contrast, basically the background is here white, and when you make it a lower contrast, the walls become very light, and then the background also very light. Okay, so you can see the lower contrast. Sometimes when we want to take photography images, this type of images is accepted because it's very looks so very nice, because it looks like a filter. Because if you see there's certain images where we can use filter, there's and nowadays we have so many apps and people using filter. This is the way they use. So the one basically now we are using codes to actually make it a lower contrast, but that already built in filters to actually make this. So it looks very nice. Okay, if you see this is very clear, you can see the difference, especially the water splashes, the bulb. Okay, see here the flowers, so much difference, the lower contrast and the high contrast. I use the word high and low, which is the same as good and bad, good and poor. Okay, so we're done with that. So now the last part is on computation of variance, which is very important. Control X, and then I'll bring it, just going to delete this. Okay, and we don't want this. I'm just going to, okay. So now we're going to calculate the variance. To calculate the variance, we're going to use double. Why I'm using double? Because in terms of bytes, so we're going to use that in terms of bytes. So double is very important because we are going to assign as 8-bit pixel. 8-bit assigned as 8-bit I mean assigned as 8-bit, and I'm gray and I'm full, so we're going to use the gray, basically the gray from here, which we have changed to gray scale, and then we once we have lowered, so we use IMG gray poor. So first row, this should be in the first row, I mean first column, and this is the second column, and J is basically basically the row. So actually why I'm using loop, where J is equals to J plus 1. So I've already displayed up here J is equals to 1, so every time it will be looping. So if you see, for example, J is 1, so J is equals to 1 plus 1, so it becomes 2, and then it bring up here 2, and then it will bring down here. So it's actually a looping part where 2 and then comes here back, 2 plus 1 3, and then 3 goes up here. So every time all the rows will be displaying accordingly. So this will be the third image, the fourth image, the fifth image. So basically like that. I think I've explained what's meaning of J here, why I'm using J. And yes, of course, we're using image variants where there are altogether 30 images and then 30 rows and also 2 columns. So basically we're showing 2 columns and 30 altogether. There'll be 30 images. So I'm going to run this. Okay, if you see my J here, my J here is altogether 31. Why 31? Because it will plus and make it 31. And then my image variance here is altogether, I can see all the variants. So let me display it here. If you see, all the image variants has been displayed. So this will be what I mentioned here is altogether there'll be 30. So it will be looping first, second, third, fourth, and like that, and it's spread here. So this will be all the high. If you see those very high, it's very high here and it's very low here. So it means this is all the one with IMG gray, all the good contrast, and this is IMG gray poor image, which is very poor contrast. So listed all 30 here. So now we're going to compute this. We're going to use t-test. So I'm just copied this here in my Excel. I've already copied. So because I don't want to, take time to copy it here. So I'm just straight away brought it here already. Okay, so this is good and bad. So since we're using high and low, so I'm going to change this to high and low. High, low. Okay, so now I'm going to use t-test. Okay, I'm going to explain on t-test. Before I'm explaining on t-test, let me I think I've done all the verification here. So the coding is already done. So now I'm going to use t-test. Okay, to use t-test, we're going to use equal t. If you press t, it's already here test. So basically we are just using here array one. Array one is basically, we're going to start from here, which is A2. And then we're going to bring until A31. Okay. Okay, and then there's a comma. And array 2 will be until here, which is on B2. Dot B31 as usual. So all this thing, and then, sorry, capital B, B31. Okay, comma, and it is one tail distribution. Why are we using one tail distribution? It's just because one tail here means showing that what are we going to because all these are positive. You see, all here is positive. Since we're using all these are positive, therefore it is one tail distribution. T31. Okay, one tail distribution. Okay, and then the type here is pad. Why are we using pad? It's just because, so why are we using pad? It's just because we are using how do you call this, because we're using good and poor. So basically we're using two for pair, we are pairing it good and poor. So that is why we're using pad. So we are comparing with two images, two types of images with different contrast. The same type, actually two types, two same type of images with different contrast. So that is why we're using uh, pad for pad here. Okay, so we are done with that. So now since we are not able to see this properly, so we're going to change this to, I mean, it's an exponential negative 13, which is very small difference. So we're going to make this as number over here, numbers. Okay, as number. But it takes some time to actually give me the entire number. Enter. Okay, I'm not going to do number as usual. I'm going to use function general, and then I'm going to change it to number, but I have no idea why is it still 0.00. Okay, never mind. So negative 13. So this will be my my t-test value, which I use from A2 to A31 and B2 to B31. So basically my values are from A2 until A31 and B2 until B31. So this is my value. So if you see, the difference is very small. So so now what is t-test? Okay, t-test here is used to compare to compare the contrast between two images, basically to actually compare the variance. So now the output of the t-test is I've already shown you the t-test output here, but I'm not able to change it to number. It's still showing me 00. Okay, so I made it in general itself because it's not I mean, it don't seems to have specific format. Exponential negative 13 is very, very small. And so I'm going to conclude here. So I'm going to make this as C1. So I'm going to put a conclusion here. Okay. So my conclusion here, I'm going to put it here, this over here. So I'm going to use the word since. Okay, actually we're using to change the number is so that it's easy for us to actually find the probability. Basically, we're using t-test is basically to find the probability in terms of the threshold, where if you see to check the variance, whether the image is whether it's significant different from each other. To actually check whether it's significant or not, we have to see the probability. Okay, 0.05, 0.05. Okay, if you see the threshold is 0.05, and there is significant difference between the variance of good and, I mean, we are using low and high and low, right? So it should be high, high and low contrast images. Not images, just low and high contrast. Okay, so if you see, okay, over here we're going to see the difference to actually so that okay, to actually see the difference, to see the difference, we're going to use high minus low. So when we're going to use high minus low, it should be A1, A2, sorry, A2. So if you see, the difference is 790,003. So I'm going to do this. So this is the difference. If you see, all the difference here is very less. So to see the difference between 5421.24 minus 869.28, the difference here is very, even though it's all positive, so it's since all positive, the difference is very lower, I mean very low. So therefore we're going to conclude this as therefore okay. So we got, this is the conclusion. Basically what I mean here is, the conclusion is when we see the when we use the t-test, and when we got the t-test is very low, and you can see all the data here is all zero. Okay, all the data here is all this data here is all not zero. I'm saying that it's all positive, it's not negative. Therefore it is lower than the threshold of 0.05, and there is a significant difference, a small difference between the variance of high and low. Therefore we can say that I mean, when we're using variance in terms of checking the contrast of an image, is very useful. So this is the conclusion, sir. So basically I'm saying that it is lower than the threshold given. Therefore, it is very significant difference, very small difference between the high and the low contrast. And then the variance part here is very useful in terms of measuring the contrast of an image. So this is my output. Basically, I've already satisfied the output here. And then also I already said why are we using t-test. T-test is actually to use to compare why are we compare high and poor contrast in terms of using variance. And then one-tier distribution just now we used is just because we are using all positive values here, all the positive values. If we see all the things that are all the values that I got for my image variance is positive, and we are using 30 times 2 image variants, so altogether there are 30 images. And I also have stated what is the output of the t-test is actually to check the probability whether it's low or high. Why I'm saying it's low is because the t-test value is very low, and it's lower than the threshold. The threshold is 0.05. And yes, the significant difference is there is a significant difference, a small difference it means. And then that is why, and I got to know that my output here, I mean the difference between the low and high is all positive. Therefore I'm saying that we can conclude that the variance is useful in measuring the contrast of an image. So so thank you so much, sir. So this is what my output here. So I think I've already gone through each and everything here. The conclusion is here, since the result shows that the image is there is it's the probability is very low, because it's lower than the threshold given. Therefore therefore we can conclude that the variance is a very suitable thing that we are using to check the contrast of an image. Okay, so thank you so much, sir, for listening to me